The objective of this lesson is to solve real-world problems using operations with decimal numbers. This lesson is a task intended to apply students' knowledge of decimal numbers to a real-world problem. There are multiple strategies and methods that can be used to solve the problem presented. Let's begin with our task. John, Diego, and Martin went on a road trip and decided they would split the cost of the trip equally between the three of them. Find the total amount of the money spent using the receipts from the trip and divide to determine how much money each person is responsible to pay. Diego wants to determine how many hours he needs to work to earn his share of the trip expense. His job pays $15 each hour he works. How many hours will he need to work to pay for his portion of the trip? Round to the nearest tenth of an hour. Let's start by getting the total cost of the trip. One strategy would be get a sum on each receipt and then add all those receipt sums for one large total. Let's start with the supermarket receipt. $3.45 plus $6.78 plus $3 plus $1.20. Write these vertically and pay careful attention to line up the digits in the correct place value spot. The total for the supermarket receipt is $14.43. The next supermarket receipt is already totaled for us. This is $81.29. The third receipt is for the restaurant bill. $25.12 plus $9.35 plus $18.41 plus $7.99 equals $60.87. The final receipt is for the hotel. The bill states it was $82.73 per night. They stayed for 3 total nights. One way to solve would be to add $82.73 3 times for a total of $248.19. Another way to solve would be to multiply $82.73 by 3 for a total of $248.19. At the bottom of the hotel receipt, it states they received a $25.97 discount off their total bill. So $248.19 subtract $25.97 equals $222.22. Add up each receipt total for a total amount spent. $14.43 plus $81.29 plus $60.87 plus $222.22 equals $378.81 was the total spent on the trip. Then take this total and divide it by the 3 people. One strategy would be to use the partial quotients algorithm to divide. This strategy is a very effective and efficient strategy to use when dividing multi-digit dividends. This strategy also aids in aligning the digits in the correct place value. $378.81 divided by 3. Start with the hundreds place in the quotient. 3 times how many hundreds is close to $378.81? 100. Record 100 in the quotient. Write the 100 with a decimal at the end followed by 2 zeros. This will keep our digits aligned to the hundreds place as we continue dividing. 100 multiplied by 3 is equal to 300. Subtract 300 from the dividend. There is $78.81 left to share. 3 times how many tens is close to $78.81? 2 tens. Record a 20 in the quotient, above the 100, with a decimal at the end followed by 2 zeros. 20 multiplied by 3 equals 60. Subtract 60 from the dividend. There is still $18.81 left to share. 3 times how many ones is close to $18.81? 6 ones. Record the 6 above the 20 in the quotient, with a decimal at the end, followed by 2 zeros. 6 ones multiplied by 3 equals 18. Subtract 18 from the dividend. There is still 81 cents or hundredths left to share. 3 times how many tenths is close to 81 hundredths? 2 tenths. Record a 2 in the tenths place above the 6 with a decimal before the 2 and a 0 following the 2. 2 tenths multiplied by 3 is 6 tenths. Subtract 6 tenths from the dividend. There is still 21 hundredths left to share. 3 times how many hundredths is equal to 21 hundredths? 7 hundredths. Record a 7 in the hundredths place of the quotient with a decimal followed by a 0 in front of the 7. 7 hundredths multiplied by 3 equals 21 hundredths. Subtract 21 hundredths from the dividend for a difference of 0. There is nothing left to share. Add up each partial quotient for a total of $126.27. Each person owes a total of $126.27. The next step in the task is to figure out how many hours Diego must work in order to pay for his portion of the trip, and round the answer to the nearest tenth. Divide the $126.27 by $15 per hour. Let's use the long division algorithm with recorded zeros to solve. This means each time a partial quotient is written, it will be written with digits out to the hundredths. Start with the hundredths place of the quotient. 15 times how many hundredths is close to $126.27? 0. Record a 0 in the hundredths place of the quotient. Next, move on to the tens. 15 times how many tens is close to $126.27? 0. Record a 0 in the tens place of the quotient and move on to the ones. 15 times how many ones is close to $126.27? 8 ones. Record an 8 in the ones place. 8 ones multiplied by 15 equals 120. Subtract 120 from the dividend for a difference of 6 and 27 hundredths. Notice the 120 has a decimal followed by 2 zero placeholders. This is to aid in the alignment of the digits. Move on to the tenths. 15 times how many tenths is close to 6 and 27 hundredths? 4 tenths. Record a 4 in the tenths place. Make sure to put a decimal in between the 8 and the 4 to keep the digits in their correct place value. 4 tenths multiplied by 15 equals 60 tenths. Subtract from the dividend for a difference of 27 hundredths still left to share. The problem asks for the answer rounded to the nearest tenth. In order to decide if the tenth will stay a 4 or be rounded up to a 5, the hundredths must be divided out. 15 times how many hundredths equals 27 hundredths? 1 hundredth. Record a 1 in the hundredths place. 1 hundredth multiplied by 15 equals 15 hundredths. Subtract from the dividend for a difference of 12 hundredths. The 1 in the hundredths place means the 4 will remain 4 tenths. Diego must work 8 and 4/10 hours to pay for his portion of the trip. The objective of this lesson was to solve real-world problems using operations with decimal numbers, and we met this objective by adding and multiplying decimals using standard algorithms. We also divided decimals using the partial quotient algorithm along with the long division algorithm with recorded zeros.